to see the second case where the maximum power transfer theorem for AC source. The source is AC here. Okay, source is AC here. This is internal impedance of AC source, and load is actually pure resistance. Load is pure resistance. Then for what value of RL, the maximum power will be delivered to the load from this source. So for this, okay, the AC source source impedance being complex and load impedance being pure resistance. So this is source impedance is also AC R naught plus JX naught, and AC voltage source value is V at an angle 0, and load is pure resistance, and it is a variable. You have to find out for what value of RL maximum power will be transferred to the load resistance. So for this circuit, the statement is the maximum power will be delivered from the AC source to the pure resistance load when RL is equal to magnitude of this source impedance. This is R naught plus Jx naught. Its magnitude is root of R square plus X square, X naught square. So the value of RL should be root of R naught square plus X naught square, or magnitude of your source impedance, that we have to prove now. Okay, let us take the proof now. Write here one current IL, load current IL. Current through RL is given by this AC voltage V naught, V at an angle 0 divided by this Z is R naught plus JX naught. So you have to write Z as R naught plus R naught plus JX naught plus this RL. Okay, plus this RL. You have to write one more statement here. Right, I will try to write if possible. Okay, I is given by V at an angle 0 divided by Z. Okay, Z plus RL. Okay, where Z is R naught plus Z plus RL, where Z is equal to this value. Z is R naught plus Jx naught. So you write here R naught plus Jx naught. After that, you add all the resistance R naught and RL. R naught and RL are resistor now. So add it. And imaginary part Jx naught you write as it is. Now, since power cannot be imaginary, considering only the magnitude, you have to consider only the magnitude of this. So magnitude is, you have to take root of R naught plus RL whole square plus X naught square. Voltage divided by root of R naught plus RL whole square plus X naught square. And power is given by I square into RL. Power is given by I square into RL. So IL value, if you take square, you'll get V square, and this root will get cancelled. You will get only R naught plus RL whole square plus X naught square. And this multiplied by I square into RL. This RL you write here. V square by R naught plus RL whole square plus X naught square is the current square value, and power is delivered to only this is load is RL only, no? So we have to write RL. Again, to find maximum value of this power, you have to differentiate this P value, power value, with respect to RL, because RL is a variable. You have to differentiate with respect to RL, and you have to equate to 0. So denominator whole square, denominator is R naught plus RL square plus X naught square, whole actually square, denominator is full thing, is full denominator square. Okay, again denominator you write as it is, and differentiation of numerator, V square is a constant, differentiation of RL with respect to RL is 1. So you are going to get first term, second minus numerator is V square into RL, and you have to differentiate this part. you have to differentiate whole denominator with respect to RL. Remember, here RL is variable, R naught is constant, X naught is constant, voltage is constant. R naught is constant, X naught is constant, voltage is constant, only variable is RL. So if you differentiate denominator, okay, here uh, 2 square R naught plus RL, 2 square R naught plus RL into differentiation of R naught with respect to RL is 0 into differentiation of RL with respect to RL is 1. So you'll get 1 here plus difference again differentiation of X naught is constant, X naught square is also constant. So differentiation of this constant is 0. So you'll not get any 2x naught. Again dx minus dy naught is 0. So whole thing is 0. So consider this full thing is a constant and differentiation of this one is constant. So you're left with only 2 square R naught plus RL into differentiation of R naught with respect to RL is 0. RL with respect to RL is 1. So we'll get only F. And if you equate this one to 0, if we equate this one to 0, this implies, okay, denominator cannot be 0. If you cross multiply this into 0 is 0. So divide throughout by v square. Okay, then this quantity numerator, this quantity should be equal to 0. That is numerator v square r naught, you square it, r naught square rl square a plus b whole square, a square plus b square 2ab. Okay, r naught square rl square 2 r naught rl plus x naught, this x naught you write here, and minus v square at 2 r naught rl 2 r naught rl plus 2 rl square plus 2 rl minus, here minus is there, so minus 2 rl square. So this 2 r naught rl will cancel with 2 this rl and divide throughout by v square. So v square is also 0. Okay, this v square also will get cancelled. So this part is 0. So this and this will be cancelled. And now you can check r naught square. This is minus 2rl square and rl square. So we'll get minus rl square and x naught square is equal to 0. And you bring rl square to right side. So rl square is equal to r naught square plus x naught square. So this is nothing but magnitude of r naught plus magnitude of r naught plus jx naught. That is, this is the value of source impedance z is equal to r naught plus jx naught, and the magnitude of this is given by root of r naught square plus x naught square. So this RL should be equal to magnitude of this. So that is the second statement. In case of AC network where AC source is there with internal impedance r naught plus jx naught, and if the load is pure resistance only, variable resistance, then what is the value of this RL is? For maximum power transfer, RL should be equal to the magnitude of this source impedance. So this you have to prove. So you have to see the question properly. Okay, there are different cases where for AC sources they may ask source is load is only resistance. Sometimes load is also impedance will be there. So this also impedance will be ZL will be there with R variable and XL variable, both variable. There are different cases are there. So maximum power transfer theorem actually it has three statements, and for all derivation is there for maximum power. We have to derive it. They ask. So first one is for DC network, RL should be equal to RS. Okay, load resistance should be equal to RTH. If it is a AC source and load is only RL, then RL should be equal to magnitude of source impedance. Okay, thank you.